Hey guys, and welcome back. So now we're going to take a look at the rooftop, and it's made of three elements. I have the tiles, and I have planks supporting the tiles, and I have wood structure. And I have wood structure like this. The wood, we've covered it pretty much in details in all the previous videos, so for this one I'm just going to use a simple Voronoi and a simple constraint network, glue constraint network, and then for these tiles we're also going to use a glue constraint. It's very simple, we don't have any crazy motion needed here. The only thing is I'm going to fracture this using Voronoi and also create a constraint between the edges of these blocks. And I want to show something a bit more, maybe not, I'm going to show something more evolved than what is required for this, and I want to show you guys a few more tips and tricks about solves. So let's, let me copy that. And what I want to do is I want to create connectivity between these blocks. I want to create two connections and use those as a pin constraint to allow these guys to rotate. So for example, we'll have all these planks being able to rotate and swing next to each other, and then we're going to fracture each one of them with Voronoi and use a glue constraint to hold all its pieces, but they're not, the Voronoi here and here will not be connected by any strong glue or any strong constraint except the two connectivity that we're going to make. So let's create a few things. Let's set up a connectivity node and I want a class attribute, and then I'm gonna loop over. So my goal is to create 2 points on each side of this geometry, okay? And then once we have that those 2 points, we're gonna run a connectivity connect adjacent sub and try to build a connection from there. So let's do for each connected piece, let's loop over these guys, and what I'm going to do is I'm going to delete everything except the biggest faces, okay? So as you can, if we look at the geometry, we always have one flat face that is much bigger than all the others. Okay, so first of all, I'm going to fuse the points. And I'm going to average them. And this way it's going to flatten everything. So if we use a small radius, we now have something in the center of this geometry. Okay, and then I'm going to sort. If we look at the primitive number, here we have, in this case, 0 is being the biggest one, but that's not always the case. And after the fuse, the order will change as well. So we want to measure, like we did earlier, we want to measure the size of these primitives and sort them using that attribute. Not measure, but area. And we want to reverse that. So now, pardon me. So now we have, let's make sure. So now we can delete everything except primitive number 0, and that should give us the biggest side. Okay, next I'm going to convert these this geometry into curves, into lines, and we can use a node called convert line. And now we have 3 separate pieces. I'm going to use a primitive node, and I'm going to scale this down. Now see, even though there are 3 primitives, they're not separate primitives, so the scale is not working on individual ones. And I'm going to put down a facet node and separate them using the unique and cusp. We don't need the cusp, we just need the unique points. And now we can scale this down. And if I template the original geometry, you can see we have not this, but this. We have 2 points. Okay, we have a primitive and each has 2 points. So let's put down an add node and delete geometry but keep points. And now we have our points. So let's run this on all the guys, and let's template the original geometry. And you can see we have 1 point on each side, 2 points on each side of this geometry. Cool. So this is great. I'm going to keep this, and I'm going to fracture this geometry. Let's put down a VDB from Polygon node, and let's generate an isosurface. Actually, I don't need an isosurface. It's very flat, so we can simply scatter points on this, and I don't need relaxation. I'm going to use a point replicate node, and I'm going to copy this. I'm going to generate 100 points and replicate these guys just to create something with more variety on it. So let's set this to 25. Sphere, add some noise, and let's scale these spheres. Okay, now they're all floating everywhere. I'm gonna ray them onto the geometry, and I'm gonna use the minimum distance. Okay, so this is just a way to get more variation, that's all. And for no fracture, cool. So now we have a lot of pieces. I think it's too much, so let's lower this to 400, this to 30, yeah, something like that. I just want it to be light. And what I need to do now is I want to generate a connectivity only where there is those 2 points. And let's name these guys. Let's call this rooftop tiles. We cannot run the connect adjacent SOP here on these guys to connect them because there is no name attribute, and now we have also new geometry. So even though we have points there, it doesn't relate to the original geometry. Now it needs to know about the name of this piece. So what I'm going to do is I'm going to promote the name attribute from a prim to points. Okay, and let's delete everything except the outside. So inside. Okay, so now we have the outside, and I'm gonna scatter a lot of points. More. I want this to be very dense. I don't need to relax the geo. I don't think I need 1 million. Let's set this to 1. Yeah, this is 1 million. I think it's enough. Yeah, it's we have a lot of details. And then I'm going to transfer the name attribute from these points onto these points. So name, and that's it. We have a name attribute now here. And we can now run the connect adjacent SOP on these guys. And you can see it's building our connectivity. I'm going to lower the radius. And let's template the geometry, the original one. And you can see we have a link in between. So I'm going to use that as a pin constraint. And we'll have some breaking rules for these guys. If they bend too much, we're going to break them. But it's not operating on this geometry. It's going to operate on this geometry. Okay. And so the next thing is we need a glue constraint that holds all of this. It doesn't have to be a glue, but I'm going to simplify it a bit. And we're going to create a glue constraint that holds everything together, but I don't need it in between. We can do something similar to like we did with a glue constraint, where we generate a, sorry, not the glue, but the wood structure, where we delete it based on the name based on the ID of the original piece. We're not going to do that. I'm going to do something simpler. So here I'm going to do for each named primitive, and remember we made a class attribute here that's still valid here. So if I do color node, and let's visualize that. I have a class attribute for each of these guys. So I'm simply going to use that to loop over these blocks of Voronoi. So now we have this block, and here I'm gonna use a connect adjacent sop. I'm gonna set it to surface, and this is, if we run it through all of them, it's gonna treat each one of them individually. So there is no connection between the neighbors. Why is this too long? It shouldn't generate connectivity between the blocks. This is... Yeah, so this, I'm not sure why it's doing that. It should be a clear cut between the blocks. Okay, let's try again. Let's lower the search radius to 0.05. And I'm not sure now why. Okay, let's do a single step. Okay, so we have that. We have this. That's correct. That's correct. Let's try number 20. 50. Yeah, it's working, but I don't know why it's connecting in between guys. Could be, could be something wrong with the name attribute. This is really bizarre. Yeah, it should be... It shouldn't create any of these links. And I'm honestly not sure why this is happening. Okay, let's take a look at one more thing. Let's take a look at this guy. Okay, so the Voronoi fracture itself generates a glue constraint for all the pieces, and it's holding, it's only connecting the core. So I'm gonna use this for now. We don't have to generate one, but this method I've had it in the file just a few minutes ago, and it was working just fine. It doesn't make any sense for each named for each primitive. Okay, and I'm not gonna use the name. I'm gonna use the class attribute. And connect adjacent pieces. This is really weird. Okay. Yeah, I'll double check and see what's wrong later, but I'm very confident that it should work. I've had it working a few minutes ago, and for now I'm going to use this as my glue constraint. And again, I just want something to hold these blocks together. Cool. So this is good. And then for these guys, I'm gonna fracture this this geometry. Maybe we can do the same thing we did here. I'm gonna copy this. Okay, I'm gonna fracture these guys, and we'll also use the glue constraint from this node. Just put down an all. Yeah, this works. No, I want something to hold them up a bit tighter, and I'm gonna call this roof wood. Something like that. This is to hold the structure. I'm gonna merge them with these guys. And then this is going to be our pin constraint. I don't need pins for this. And then for these guys, I'm going to simply I'm not gonna fracture them. I'm gonna use them like this. I don't want to fracture the tiles into more details. And one thing I know is that this geometry has some issues. You can see here there's floating pieces, and there's a lot of small things that's gonna cause some issues with the sim. So what I'm going to do is I'm gonna compute the volume of these guys and then delete anything that is really small. And we've already done this for the mass, to compute the mass, so I'm gonna copy that and paste it here. And let's measure. And let's first assemble these guys so we get a name attribute. I'm gonna call this roof tiles. Okay. And let's change something to force this node to recook. And let's do a color node and visualize the mass attribute that we made. And it's a ramp. I want a ramp from attribute. Let's set this to white. Cool. So you can see everything that is black is very small. I wouldn't say very small, but it's small. And I'm simply going to delete these guys. Blast. If color is less than 0.5, I want to delete the points. And let's put down a color node. Made some gaps, so let's play with this. Yeah, something like this. Okay, and then I'm gonna use a connect adjacent SOP and connect these guys. That's our tiles connection, and we'll maybe have a different value, a different rule to break these guys because I want them to be weaker. But for now I'm gonna merge them with everything else, all the glue constraints and pin, and we'll set a few things up. So I think that's pretty much it for these guys. I'm gonna copy a few things from here, mainly the name. So I want this is going to be a pin. I'm going to create a separate constraint network. This is our pin, and let's put down a primitive node, a facet node, and scale them to 0. Okay. And then this guy and this guy, I'll merge them together, and I'm gonna treat them as one. So I'm gonna call this glue roof, and then for this, for the tiles, I'm gonna call them glue tiles. And let's merge everything. And this is out roof CST. And let's merge a few things for the RBD geometry. So we need this node. I'm gonna object merge that. Object merge this too. And then this guy. Gonna merge them all. And this is going to be my roof tile. Let's move this up. My roof tile RBD. And I also want to make sure that we have some active and inactive attributes. So I'm gonna copy the parts from here. And also we need to scale these guys by 20 units. So transform 20. And let's take a look. So everything is active. I'm gonna group some stuff. And let's assemble and pack them. Something like that. I want to make sure that I include some wood as well. And then for this side, I'm gonna I have to include some wood structure too. Okay, that's it. And that's our out RBD. So let's copy this and let's go to this node, create an RBD packed object. And I know there's a lot of repetition here, but this is what we have to do. It's work that needs to be done. So roof all, and then we need the constraints. So let's create a constraint network. And this is roof CST. Yeah, roof CST, and then we need a glue constraint, and then this is glue roof, I think, glue tiles, and I need a hard pin constraint, and this is going to be called pin tiles pin. Okay, let me check the names. So we have a pin, we have glue roof, and glue tiles. Okay, let's merge them all. And I'm gonna copy the subsolver from this. This is fine. I'm gonna copy the subsolver here, and I'm gonna use this only to break the pin constraint. So if at name constraint name equal pin, and we want to use the angle like we always do with a pin constraint. So if angle is higher than, yeah, let's leave that. I'm gonna change the name. And that's for the wood. Sorry, not sure which one this is. Oh, this is for the extra in-between connection. Yeah, that's fine. Yep. Okay, so here I'm gonna make sure that I change the import path as well. So this is constraint number 4. And that should bring in the correct geometry. If we did everything correct. Cool, we have the roof, and I'm not gonna use these guys. I'm gonna use the roof and Kong. I know there's a lot of intersecting geometry, but let's see how bullet behaves for now. And let's take a look at our constraint network. Let me disable this. Okay, so it's not working. Then it means something is wrong with the system. We have to be able to view it here. So let's go back. And the reason for that, I believe, this is correct. We have a name attribute here. We have a name attribute here. Let's check. Okay. I'm not sure why it's not showing up at the moment. Yep, we didn't change these guys. So glue tiles. Yeah, it's working. And this is pin. I'm gonna set the rest length to 0 here. And let's see how this goes. Yeah, it's working. Okay, let's hit play and see what we get. Maybe it's gonna work. Maybe it will crash and we have to fix it. Okay, it looks like something is working. Okay, let's see. I'm gonna lower the strength to 10 on all of them. And let's make sure we have an active attribute set up correctly, because it feels like... So here active is 1. Oh yes, see? Because we did the active before the assemble. So simple stuff like that. You can spend a day looking for it. Let's set this back to 1000. Set this back to 1000 as well. And let's hit play. And it is working. So I think the wood structure here is very weak. So we want to increase that. I'm gonna increase everything. So let's try this. Roof tiles. And as you can see, things are gonna, maybe they will fly out a bit, but they're gonna start crumbling as Kong passes through and T-Rex is gonna come through. So what I wanted to do is to introduce some fake forces that explodes everything upward and make it feel as if there's a lot of impact happening under the hood. So we're gonna do that in the next video. For now, I'm going to fix the strength on this and lower the number of pieces we have on the glue on the wood structure. I don't need this many pieces, and I think that's pretty much it for now. I think the tiles is it's holding itself up pretty well, but the wood structure here is very weak. So let me check that. So where is that? That's correct. So here's what I'm gonna do. I'm gonna change this to glue roof. Yeah, glue roof planks. And let me copy this. And then I'm gonna create a separate glue constraint for these guys. And let's increase the connection between them. Yeah, I want it to hold itself up a bit more. And I'm gonna call this roof, glue roof wood. And let's also reduce the number of pieces. Okay, so we have these two guys. Let's go back in. So I don't have this anymore. And I'm gonna increase the strength here. And let's create a new one. And let's increase this as well. And I'm gonna set all of this to 0 on this one. Let's do one more test. Yeah, what I'm looking for is that I don't want the wood structure to just start falling. Come on. Yeah, much better. It is falling. So let's I'm going to make some more pieces here inactive on the wood itself or on the entire roof tile. And then I'm gonna increase the strength of the glue constraint on this guy. No, we made a mistake. I didn't add the glue constraint correctly, so I didn't copy the name. So this is glue planks and this is glue wood, roof wood. Let's make sure we have a glue constraint for that. Okay, let's hit play. And now it is much better. Yep, I mean it's working. It wasn't working before. And we have the pin between these the planks. You can see that's the connection there. So that's gonna help make this fluid, all of this bend and deform together. I think the force is a bit too strong. So let me lower a few things. Let me lower the tiles. Actually, I want the tiles to be really weak. And the roof maybe 5. And we'll keep the wood structure as it is. I'm gonna go up. Let's check for the bullet settings. Okay, that's fine. I'm not going to include everything in this test. Let's copy this name, and here I just need the roof all, and let's write this as V19, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.